The escalator, one of the hardest working machines around. At one of London's busiest metro stations, it shifts up to 13,000 people an hour all year round. But getting caught in such a powerful machine can cause serious injury. So how does it lift more than 100 people at a time, smoothly and safely? More than 10,000 moving parts work together. A tough steel cage on the outside takes the weight of 30 armored tanks every hour. 157 aluminium steps travel so far in their lifetime, they could go to the moon and back, yet always stay level. A heavy-duty electric motor can lift the weight of 2 elephants. This is a multi-million-dollar workhorse, powerful and built to last. When full of people, this escalator weighs 54 tons, the same as 18 SUVs. So it's got to be incredibly tough. The key to its strength lies in the way engineers build its frame. At this 15,000 square meter factory in Illinois, the frame starts life as 11-centimeter thick steel beams. Workers cut these to precise lengths, up to 1,500 per escalator. Crack welders then turn this pile of metal into a huge reinforced cage called a truss.
This unit's 104 foot long. You got to have good, strong welds.
Butch makes the panels that form the truss sides and base.
I love welding. I started here in January of 1973. Been welding 37 years. These diagonal pieces actually keep it solid. That's why you see so many of them. Yeah, we make them as tough as possible here.
But being tough isn't enough. Workers must fit these side panels together to form a rigid cage with supreme precision. Otherwise, the stairs could jam. So they hoist the panels into a huge metal guide frame.
That feels real good right there. This yellow fixture, it has a series of plates along one side that are all set in line straight. And when we put a side on up against these stops, we'll put big C-clamps on like that. That's the key to getting a true straight escalator.
The end result? A giant steel cage, accurate to within a few millimeters, all the way down, and strong enough to lift 140 passengers in a single ride. So how does it pull such a huge load? Hidden under the top of the escalator, a giant electric motor works round the clock. Inside, 2.5 kilometers of copper wire and a huge electric magnet spin a drive shaft 700 times a minute. This powers a set of cogs that gears down the revs and locks into a 6-centimeter thick chain. The massive drivetrain pulls the steps upwards at exactly the same speed, no matter what the load. The steps are part of a hugely complex mechanism. Any big bumps or vibrations could knock passengers over, and it's a long way down. The secret to making sure that doesn't happen lies in the way workers put them together, by hand.
We just take pride in what we do. You know, I build it as if it was mine.
Tab fits the drive chain and steps on some of the biggest escalators in America.
The escalator itself will have a 77-foot rise, so that's almost 8 stories. The unit is 188 feet long. The steps are attached to the chain with step pins put together correctly. With the dimensions set properly, the escalator runs smoother. Clear!
The steps themselves also play a big part in making sure passengers don't feel any bumps in their ride.
This escalator, once it's completed and installed, will have 269 steps. A lot of steps. Each step has 2 sets of wheels. It's our trail wheel. Rides on a piece of flat track that keeps everything in line so it can rotate around the escalator virtually rub-free, noise-free, and safe.
This flat inner track solves one of the fundamental problems of escalator design, keeping the steps and the people on them level all the way up. So how do steps form a rigid staircase on the slope, then collapse into a flat platform so people can get off? The 2 sets of toughened plastic wheels on each step run on completely different tracks. The front set hooks up to the drive chains moving the escalator. The rear set locks onto the inner track. As the steps rise, the tracks draw close together and tilt the steps to form a staircase. At the other end, the tracks move apart again, so the steps make a platform and you can get off. But the combination of moving metal with lots of power has a flip side. Getting caught and dragged into an escalator can cause serious injury. So the first rule of escalator design is safety.
It hurt you. We don't want that. We want everybody to be safe getting on and off our escalators we build.
Sean installs one of the most important safety features, the comb plate.
The key safety features from anything getting sucked underneath. Yep, everything needs to be square.
The cone plate protects one of the most dangerous parts of an escalator, where you step off at the end. Here, a moving step meets a static landing plate. If this trapped clothes or shoes, it would be disastrous. But this almost never happens thanks to the way the cone plate meshes with the deep grooves in the escalator steps.
Well, the steps got the grooves in it so it could line up with the cone plate segments. So any type of debris that's in a crack, they're gonna ride up on top of the cone.
It's a simple system that keeps passengers safe. And it's the reason all escalators have grooved steps. Once everything's installed, it's time for a full-speed test.
At this point, we are running it as a final checkout, making sure there's no noises, no pops.
Shannon makes sure every escalator runs as smooth as butter.
We have to make it as smooth as possible. You've been here long enough, you'll feel if something's not right, and we'll correct this, make it as quiet as possible before it even goes out the door. And if you're riding on an escalator, you don't want to hear noises. You definitely don't want to hear noises.
The steps are running smoothly, so this escalator's ready to ship. Across Europe, over 75,000 escalators transport millions of passengers every single day. We walk all over them, but these unsung heroes work long hours, pulling tough loads to keep our subways, malls, and cities moving.